In today's lab, we are going to do the HK modulation and demodulation together. So again, we'll go to MATLAB, we'll click on Simulink, open a blank project, blank model you can say, and then library browser. And library browser, we will download or can say send all the things which we require for the model. So first one we are going to use a Bernoulli's binary generator. Basically, it basically generates a binary number in a random way. Then again, sine wave. Then we need a switch. Then we need a product, mode block product. Then we need a digital filter. This thing basically is out of scope of this thing, but I'll just explain how we are using it. Digital filter, relational operator. You can just search a relation, and we are going to use a relational operator with a condition with greater than. You can see that you have a quite many number of operators, so you can use any one of them, but we are going to use a greater than one here, and a constant need. So then we need a scope. So now we have all the components required for this. Now we need 3 copies of sine wave. I'll explain you why. So can copy them, paste, paste. So the first is your, it will generate the numbers, binary numbers 1 and 0. So basically we are use them for the purpose of generating a pulse. So it will be 1 0 1 0, or may let's say 1 1 0 1. So it will generate them randomly. We have a sine wave. And then we have another sine wave. So we are using 2 sine waves. I'll explain you why we are doing it. So first sine wave, what we are doing is we are keeping its amplitude as 2, frequency as 4 pi, phase is 0, and your sample time is 0.01. Like okay. And for this one, what we are going to use as the time period, sorry, amplitude is 0.5 and frequency is your 4 into pi, and samples time is same as the one we use up. And we have a this. Bernoulli is binary connected to your switch. All of you know what is a switch by the name, but how we are going to use a switch here is that we have a greater than zero condition. So if the number generated by Bernoulli's binary generator is 1, then upper waveform will pass, or you can say upper waveform will reach the output. If it is less than 0, or you can say it is 0, then this waveform will pass. Okay, we'll see how it's working in the output. Then we need another waveform. Just give me a second. So now we have a product of this, and this, we have another wave, sine wave, which we are going to use here by multiplying with the output of this. So we have one more sine wave which we are going to use here, and then in this sine wave we are going to use amplitude. Frequency is equals to frequency, oh sorry, amplitude is same, 4 pi is the frequency, and sample time is your same as of other sine waves. We changing this constant value to 2.5. We are applying it. Apply 0.5. We need to do this. The output of this will go here, and the output of the filter will go here, and then we have a scope. We can define the number of inputs as 3 to it. Now we have this constant, and you know, the different ones, but you need to change the parameters of your digital filter. Least squares is the number of times we are using it. So it's basically, and the pass band we are going to use here is point, so it is there 0.012, 0.05. Design filter is done. Then we have this as output. We have your Bernoulli's binary data as one of the input, and we have switch output as, sorry, switch output as one of the output. Then we forgot to save it. Save as ASK new, save, and then open it. Click it. So do it. 3 different outputs of scopes we have. So we have now this thing available to us. So if you see, This is my input waveform, one of the sine wave. This is another sine wave, and then this is the first sine wave. So the bigger sine wave is this one, the smaller sine wave is this one. So when, sorry, I just need to pop up this. So when this is positive, the upper sine wave is passing. When this is negative, means your Bernoulli is number. This is basically your passing the lower sine wave, and so on. So this is basically your ASK. The ASK we studied in the lecture, it was like that when the waveform, the pulse generator value is 1, the waveform will pass, and when it's low or 0, then no output, or basically it's 0 there. So what we are doing is we are just using another waveform to pass at that time for ASK. Now, what is this? This is your demodulator output. So this is your modulation. This thing is modulation, modulated output, and this is your output. So it's working in that way. So if we go ASK here, so this part basically designed for your demodulation, and this part basically designed for your modulation. This is your modulator, and this is demodulator. In a similar way, you can do it for FSK and PSK, but that's the part of your now project. Thank you.